Hi everyone. In this video I am going to explain about two parameters, phase velocity Vp and group velocity Vg. So first let us see the phase velocity. So velocity is V and phase velocity it is Vp. So what do you mean by phase velocity? Phase velocity is nothing but it is the velocity with which the wave propagates in the rectangular waveguide or any type of waveguide. Whether it is a rectangular waveguide or a circular waveguide, that wave is having a velocity. That wave which travels in the waveguide is having the velocity which is known as phase velocity. Okay, so it is defined as, definitions are very important here. It is defined as the velocity with which the wave travels in the waveguide. The waveguide is known as phase velocity. That velocity is known as phase velocity indicated by Vp. Okay, so this is the phase velocity. It is also defined as the rate at which the wave changes its phase in terms of guide wavelength. Okay, it is another definition because according to the definition of this phase velocity, we are writing the expression of the phase velocity Vp as omega by beta. Okay, so omega by beta is nothing but I will tell you the definition, or you can also write this phase velocity as, it is also defined as the rate at which the wave changes its phase in terms of guide wavelength. Guide wavelength is nothing but lambda g. I already told you what is the guide wavelength. Guide wavelength is nothing but the wave which is traveling inside the rectangular waveguide or any type of waveguide. That wave is having the wavelength that is known as guide wavelength. Okay, so coming to the second definition, it is also defined as the rate at which the wave changes its phase. The wave changes its phase. Changes its phase is nothing but when suppose if you consider a wave, it is having a 2 pi radian. So when it is changing from one cycle to another cycle, what is the amount of phase it is experiencing? Okay, that is the phase velocity. It can also be defined in that way. So the phase velocity Vp is equal to lambda g into f. Lambda g into f. So what do you mean by lambda g? Suppose if you are taking the second definition, it is also defined as the rate at which the wave changes its phase in terms of guide wavelength. What is the wavelength of the wave that is traveling in the waveguide? 2 pi radians. So if you just use the 2 pi radians in the numerator and denominator for the same expression, lambda g into f, then lambda g by 2 pi. So 2 pi by lambda g. 2 pi by lambda g is nothing but, what is that? Beta. So rewrite this expression as, it is equal to 2 pi f by 2 pi into lambda g. So just 2 pi f by 2 pi by, take this lambda g into the denominator, that is 2 pi by g. What is the 2 pi by g? It is nothing but beta. So 2 pi f by beta. So what is 2 pi f? It is angular velocity. So Vp we can write it as omega by beta. Vp is nothing but omega by beta. So phase velocity is equal to omega by beta. This is from the phase velocity definition. Coming to the second parameter, that is group velocity. So group velocity is indicated by Vg. Group velocity. Group velocity indicated by Vg. Okay. Now, suppose if there is any modulation in the carrier, the modulation envelope actually travels at the velocity which is slower than the carrier alone, and also of course we can say it is the velocity which is very low compared to the velocity of the light. Okay, then generally any modulation wave we are taking, that wave travels in the rectangle, any type of waveguide which is having a lesser wave velocity compared to the speed of the light, because speed of the light is very high. That is the fastest signal that travels in anywhere. Okay, that is the highest speed of any light or electromagnetic signal, which is having 3 into 10 power of 8 meters per second. So the wave which travels in the waveguide or modulation signal, that is slower than this speed of the light. So the velocity of modulation envelope is called group velocity Vg. Okay, what I am talking, that velocity of the modulation of this envelope is called group velocity. So in generally it is also defined as the rate at which the wave propagates through the waveguide, and is given by Vg is equal to omega d omega by d beta. I will tell you, suppose if there is any modulation in the carrier, if there is any modulation in the carrier, the modulation envelope nothing but the message signal which is modulated with respect to the carrier. Okay, modulation envelope actually travels at the velocity slower than that of carrier alone. That means if you are modulating two signals, message signal or a carrier signal, the modulated signal is having the velocity which is slower than the carrier alone. Suppose if you are taking a carrier alone and compare to the modulated signal velocity, so when you compare these two, carrier is having higher speed compared to the modulated signal. So it is slower than the carrier alone, and as well as it is also slower than the light of the light, velocity of the light. So and of course it is slower than velocity of the light. Velocity of the light. Okay. The velocity of modulation envelope is called group velocity. The velocity of the modulation envelope, nothing but modulated signal, is called group velocity. Now from these statements we can say the group velocity is very low compared to the velocity of light. Okay, because it refers to the signal which is modulated with respect to the changes in the message signal. Okay, if you compare this velocity even with the single carrier alone, that velocity is very, that carrier velocity is very somewhat high compared to this modulation envelope signal. So this velocity is group velocity indicated by Vg. Suppose it is also defined as, we can also say it is also defined as the rate at which the wave propagates through the waveguide it is defined as the rate at which the wave propagates in the waveguide. So it is given by Vg is equal to rate of change of that previous what is that phase velocity. So you can say dw by d beta. Just previously the phase velocity is defined as omega by beta. Phase velocity is given as omega by beta. But now it is the rate of change of this phase velocity. So Vg is equal to d omega by d beta. So these are the two important factors which we generally consider in any waveguides with respect to the velocity parameters. Thank you.